Hello everyone, today we're going to learn lesson 21.3 on the volume of cones, and that is day 2. So we are doing a second day of a lesson using the volume of cones formula to figure out the volume of composite figures. Basically, composite figures are these figures that are made up of more than one figures. For example, a prism with a pyramid on top, or a cylinder with a cone on top. So let's get into finding the volume of a composite figure. In the first example, we have this composite figure that is made up of a cylinder and with a cone on top. So we are going to start by writing down a pictorial formula. So the total volume for this composite figure is the volume of the cylinder on the bottom plus the volume of the cone. And we know that the volume formula for a cylinder is area of the base times height plus the volume of the cone is 1/3 area of the base times height. And since we know that all bases for cylinder and cone are circles, we can further convert that formula into pi r squared h plus 1/3 pi r squared h. So this is the total volume formula for this composite figure. But let's break the problem down into steps here. So the first step is finding the volume of the cylinder only. So we're only going to be dealing with the first part. So the volume of the cylinder is going to be pi r squared h. That's going to be pi. The radius is half of the diameter, which is 8 squared, times the height is 19. And that's going to give us a total of 216 pi, and that will be cubic millimeters. Next, we're going to find the volume of the cone. Well, we already know that the volume of the cone is given by 1/3 pi r squared h. And the radius for the cone is going to be the same thing as the cylinder, so it's going to be half of 16, which is 8. Square that times the height. Total height for the composite figure is 32, but we got to take away the height for the cylinder. That will give us the top part, so minus 19. That'll be a total of 13 height for the cone part. So times 13, multiply all of that together, we have a total of 277.3 pi cubic millimeters. Next, we're going to find the total volume. So TV, again, is equal to the volume of the cylinder plus the volume of the cone. So the cylinder has a volume of 1216 pi plus the cone has 277.3 pi for a total of 1493 pi. And let's round it off to a decimal. And let's go back to the problem. It says to the nearest cubic millimeter, which means no decimal. So we're going to approximate it into 4,691 millimeters cubic. So go ahead and make sure you use your calculator to verify that those are the answers throughout the problem. You may go back to the video if you need to. And let's take a look at another problem. In this problem, we actually have a instead of a 1 plus 1, this is a 1 plus 1 because we have two together. So this is a 1 plus 1 figure composite. But for this one, it's going to be a 1 minus 1 because we have a cone basically carved out. It's going to be, the whole is made up of a cone shape. So we're going to need to find the total volume. That's going to be the volume of the cylinder minus the volume of the cone. And so let's take a look at the radius. So it's going to be 3.6 divided by 2. That will give us the radius is 1.8. But if you take a look at these two figures here, they have a lot of things that are similar. The height is the same. The radius is the same. So we can actually go ahead and calculate this formula to break it down further. The volume of the cone is going to be pi r squared h. I mean, not cone, the cylinder, minus the volume of the cone is 1/3 pi r squared h. And because they have the same exact dimensions, again, the radius is the same and the height is the same, we can actually combine these two and subtract. So it's like 1 minus 1/3. We have 2/3 pi r squared h for this total volume for the composite figure. So we can go ahead and start by finding the total volume, and we can straight plug in that is 2/3 pi, and the radius is 1.8 squared, height is 4.3, and multiplying it all together, it should give us the total volume of 29.2 centimeters cubed. And here is a more clear breakdown of the calculations again. So this is a 1 minus 1 composite figure, and hopefully you understand how to do that now. Next, we are going to find the volume of this composite figure, and we can see that this is made up of a cone and a pyramid together. So we have another pictorial formula that's going to be the volume of the pyramid plus the volume of the cone. And since they are both 1/3 area of the base times height, we're going to write the specific formula. And we know that the area of the base is actually, for the pyramid, is a square. So it's a 3 by 3 square. So that's actually side square, the area of a square. And the other one is a cone, so it's a circle. That's going to be pi r squared. So we're going to write the specific formula. That's going to be side squared h plus 1/3 pi r squared h. And let's substitute the numbers in. And the side is actually 3 for the pyramid, as indicated in the figure right here. And the height is actually 4 plus 1/3 pi, and the radius for the cone is going to be half of the side length, which is going to be 1.5 squared, and the height of the cone is also 4. And multiplying it all together, we have 12 plus 9.4 approximately, which is 21.4 cubic feet. So the volume, total volume, is 21.4 cubic feet. And there's our answer for the problem, 21.4. And you may go ahead and pause the video at this time to see if you can try this problem first before you actually check the answer. So go ahead and try it right now. Okay, hopefully you've had a chance to try the problem. We're going to do this, and as indicated, this figure is actually going to be a minus. So it's going to be a 1 minus 1 situation because we have the pyramid that is carved out of the cylinder. So the total volume is going to be the volume of the cylinder minus the volume of the pyramid. And we know that the cylinder is area of the base times height minus the volume of the pyramid is 1/3 area of the base times height, and that's the cylinder is a circular base, so again it's pi r squared h minus 1/3, and it's going to be a square. So the base is actually a square. That would be so let's go ahead and find the radius, the total side length, because we have an isosceles square, and we know that the entire diameter is 5. So we know that from here to here, the hypotenuse is 5. And based on that, we know that this side is a 45 degree, so therefore the side length is going to be 2.5 radical 2. And you can do the math by using a trigonometric function. The side times radical 2 is equal to the hypotenuse. So the side times radical 2 equals 5. Dividing by radical 2, and you'll have side equals rationalizing times the top and bottom by radical 2. So we have 5 radical 2 divided by 2 on the bottom, and 2 can reduce with 5, 2.5. So that is how I got the 2.5 radical 2 for the side. And the reason why we need that is because we're trying to find the area of a square, which is going to be side square. So we found that the side is 2.5 radical 2, and then square that, so it's side squared, times the height is the same height for the pyramid as the cylinder, so it's also 8. So let's go ahead and put the rest of the units. So the radius is 2.5 and the height is 8 minus this whole thing right here is going to reduce to 33.3. And when you subtract and combine, go ahead and use a calculator to assist you with this. You should get 123.8 millimeters cubic for the final answer. And that is the total volume for the composite figure after you subtract the pyramid from the cylinder. And that is, again, the answer right here. And that is the end of this lesson. So hopefully you have enjoyed learning about finding volumes of composite figures. And let's go ahead and get started with the homework. You have a book set. You need to finish your HIW and then copy the notes for 21.4 day 1, and don't forget to do your ALEKS. Have a great day.